Welcome, everyone. For those who don't know me, my name is Giselle Reis. I'm the area head of computer science for CMUQ, and I want to introduce CMUQ's Dean Mike Trick to introduce our speaker.
Thank you, Giselle. Okay, so if you don't know me, I'm Michael Trick. I'm the dean here. Look, at CMUQ, we are really privileged to have scholars and experts visit our campus to share their expertise. We created this distinguished lecture series to showcase the depth and breadth of scholarship of these visitors. So today's lecture is the Nico A. Haberman Distinguished Lecture in Computer Science. Who knows who Nico Haberman was? Excellent. The next paragraph will be useful. Lecture series is named after Professor A. Nico Haberman, head of Computer Science Department between 1980 and 88, and the founding dean of the School of Computer Science at Carnegie Mellon, the world's best computer science school. Our speaker today has just joined the School of Computer Science, and I am delighted to welcome her to CMUQ. Dr. Mona Diab is the new director of the Language Technologies Institute at Carnegie Mellon, which is home to cutting-edge research into large language models, powering generative AI systems like ChatGPT. Dr. Diab's expertise is in the area of responsible AI, particularly when it comes to natural language processing. She is a co-founder of the Consortium on Arabic Dialect Modeling, which served as a world-renowned reference point on Arabic language technologies. So prior to joining CMU, Dr. Diab was the lead responsible AI research scientist with Meta, where she changed how the company handled Arabic. Under her guidance, Meta moved away from the notion that Arabic is a monolithic language, leading to better translations and a better user experience. Dr. Diab was just awarded the King Salman Global Arabic Academy Prize for Arabic Language Technologies for 2023. We are delighted to have her here today, and please join me in welcoming Dr. Mona Diab to the CMUQ Distinguished Lecture Series.
Thank you so much for this very, very kind and generous introduction. I really appreciate it. And thanks everybody for making it. I know it's the end of the week, the end of the semester, so I really appreciate your time and your efforts for joining us here. And thanks a lot for allowing me to speak to you in this distinguished lecture series. So today I'd like to talk to you about, and can you guys hear me? I'm not sure. Is it working? Is this better? The mic is not working? It is working.
We're just going to get him.
So it's not me?
There we go.
And now it's good?
Yeah.
Okay. So back to what I was talking about now. So I'd like to introduce you to the notion of responsible thinking, which is something that I've coined, and I'm starting to think that this is going to be necessary for building the new talent coming in, new talent and new generations of computer scientists and people working in technology in general. And I'd like to show you that this is actually something that's operational. So we always think about computational thinking, critical thinking in our pedagogy, in our educational systems. But now I'd like to add, it's very loud now? Oh, okay, yeah, okay. But I'd like to add responsible thinking as a part of this trifecta, what I call a trifecta of types of thinking. And let me start off by talking about, first off, this is coming from a place of gratitude. There's a deep sense of gratitude to all my collaborators across the years, students, interns, residents, colleagues, and none of the forthcoming presentation would have been possible without them. I know people typically do this at the end. I'd like to start by doing this at the beginning, being, again, proactive, but also my advisors and mentors over the years. And a lot of the graphics that you're going to see are my own design, which basically sucks. So I need to speak to the HCII people to actually improve my presentation skills, but that's a different story. So let's start off with our identity. I'd like to just set the level ground here around what our identity looks like. So basics, science and methodology. So science is the intellectual pursuit that encompasses systematic study of structure and behavior of physical and natural world through observation and experimentation. Tenets of the scientific method are around objective observation, experimenting, inducing information, and their repeatability with critical analysis and verification validation testing. Technology. It's basically the application of the scientific knowledge to reach practical goals in a specifiable and reproducible way. Many technological advancements have led to societal changes. While technology contributes to economic development and human prosperity, it also can have negative impacts. So think about pollution, resource depletion, causing social harms, and so on. Now, my field, natural language processing, or what we call computational linguistics as well. Technically speaking, we use these terms interchangeably, but actually there is a slight difference between the two terms. So basically, just in terms of similarity, natural language processing or computational linguistics are concerned with the interactions between computers and human language. In particular, how to program computers to process and analyze large amounts of natural language data. But basically, there are some nuanced differences between the two aspects of this field. So actually, our conferences are called Association for Computational Linguistics, which is the major conference that we have. But we also have EMNLP, Empirical Methods of Natural Language Processing. And they accept the same kind of papers, right? But what is the distinction between these two? And I'd like to highlight this. So CL develops computational methods to answer scientific questions about linguistics. So what humans are computing and how, involving the nature of linguistic representations and linguistic knowledge, and how is it acquired and deployed that may help explain the distribution of linguistic data and behavior that we observe. As opposed to natural language processing, which is around, it's kind of an art and a science, but it's more geared towards the engineering aspect of the discipline, where the problems that need to analyze natural language text. So think about the metric of success in an NLP perspective is not whether we designed a better scientific theory or proved that languages X and Y are hysterically related, but rather the metric is, are we good at solutions on the engineering problem? So think about machine translation, for example, is typically judged as to whether the translations are fluent and accurate. It doesn't say anything about the way we conceive of or cognize of language internally. So in a way, the first one is really concerned about scientific generalizations, computational linguistics, and we always try to pride ourselves theoretically that we are about computational linguistics. But in reality, we're more about the second one, the natural language processing component, which is really concerned about technological utility. So in NLP, we've had huge advances. We're really living the golden age. So we devised practical and usable by lay people natural language processing technologies. So think about assistants like Alexa, Siri, Google, machine translation, ASR. ASR is speech, speech recognition, automatic speech recognition, language models, and so on. But NLP utility is really profound, and it's really ubiquitous, and it's really pervasive. And for me, our Thanksgiving dinner table, I'm married to Tunisian, so I get my in-laws being Tunisian Arabic speakers. We have Hindi friends, we have Japanese friends, we have Cantonese friends. My brother is married to a German, and by the way, I'm Egyptian. So my brother is also Egyptian, but he's married to a German. So you can imagine our dinner table is literally like this compound of multiple languages. So we use Google Translate, but we also use my little nephew for translation across the table. But also these new technologies and using emerging LLM-based generative AI. So this talk could have been generated by a language model, obviously, as most people know. And basically, we could even produce slides using DALL-E 2 and DALL-E 3. So this is some of the slides. I gave it the title of this talk and some of the slides that came out, which had much better designs than what I'm going to show you. So this is ethical considerations, access and privacy, data quality, algorithms and transparency and accountability, human-centered design, and some conclusions. So this is actually what came off the bat, just giving it the title. So we can definitely seed a lot of our talks using this technology, right? But now, it's always been impressive, I think. I mean, I've been working in this field now for 23 years, almost. And I would say that NLP or computational linguistics have always been impressive. But it's really been our secret so far, really, in like how we enable big tech. But now it's becoming disruptive and it's gone mainstream. So it's been really proliferating. And specifically large language models, they've made a huge impact. They're allowing for the development of sophisticated AI applications within NLP, revolutionizing the way we interact with each other, we interact with the world around us. They're unlocking unprecedented scale of services and systems that's spurring economic growth and efficiencies. But also the impact of these technologies on society are quite interesting. There is a potential for increased automation to the potential of creative expression, but also potential to create better and more equitable societies. However, privacy and societal challenges are abound. So what is the state of the union for large language models? There's a fierce competitive scaling race, as you all know about ChatGPT and ILK, Llama, Bard, Claude, this is just to name the few of them. And I don't know if people realize in any of this. I mean, Netflix took 10 years to reach 100 million users. ChatGPT took 2 months to reach 100 million users. So this is really unprecedented, pervasiveness, so to speak. But it has an impact on environment, especially the scale of the compute required. We just had the CTO from Microsoft visit us at CMU Pittsburgh. And he gave a talk, Peter Lee, he gave a talk about how much the compute is going into the building of, because they're investing in OpenAI, which is the company that produces ChatGPT. He said every 2.5 days, they have to invest in the size of a stadium in terms of compute infrastructure. So this is gigantic. Nobody could compete with that. I mean, maybe the Metas and the Googles of the world, but that's as far as it gets, or maybe China. But the scale is just unbelievable. And it's really cost prohibitive. So ChatGPT costs $4.5 million. GPT-4 is almost $2.6 billion. I was privy to what happened at Meta at the time. I was part of the team that produced OPT, which was the first open large language model to be out on the market. It was 175 billion parameters. It literally cost us $5 million. And that's without even counting the actual work that went into it in terms of time. So these things are really, really cost prohibitive, which basically is like something that we need to think about in terms of academia, what our investments should look like going into the future. And I'm not advocating at all for us to go in the same route as industry, actually. It's really putting us in a different situation where we need to look at constrained types of compute, but that's a different story. But basically, this is also a reflection of the haves and the have-nots. So where is academia in this picture? Let alone non-Western, non-US, Silicon Valley, West Coast voices. So a lot of this investment, if you haven't noticed, is OpenAI, the Meta of the West Coast. It's actually a very, very small sliver of the technology industry in general. But with great power comes great responsibility. So we have huge advances with truly disruptive technology changing NLP and AI. The entire narrative and the research and the whole landscape for products is actually changing. Extremely accessible, fluent, and intuitive, which garners trust almost immediately. I mean, my husband is also a technologist, and we have a lot of conversations, and we refer to ChatGPT as he and she, which is kind of scary, right? So we are people working in this, and we're already anthropomorphizing the whole, experience, which tells you something about the trust level. And I mean, I keep trying to remind myself, don't trust it. But of course, I do trust it. So it's like I have this Jekyll and Hyde situation going on. But there are lots of problems. There's the LLM's overconfidence, hallucinations and disinformation and fake information, the bias, instinctive anthropomorphization. But we are at an inflection point. So some open questions. What, where, and how regulations and guardrails? So how can we ensure the veracity of large language models? Factoids versus opinion data, provenance and confidence. So how do we actually, take these things into consideration? What's a fact? That's a really interesting question. There are some facts that are well known, like the sun rises in the east and sets in the west. But then a lot of other things that are factual could be factual at a certain point in time, but then change, over time. This could be the opinion of a person at a specific time, that's a fact, but then that person changed their opinion in a completely polar opposite way. Is that still a fact? Has that changed? So there, as I mentioned, so it's not really a very simple question. It's in fact quite complicated. And from a technology perspective, how do we identify these things? Now, we talk about regulations, but we also talk about value systems and ethical value systems. How do we actually build systems that are ethically aware, that are human value aligned? But which human, whose values do we need to embed? And right now, given the large language models that we have, apart from the bias just by the inherent bias that's only in English or mostly in English, that's already built-in bias, right? Or built-in leaning, so to speak. Now, does that come, free? No, it of course comes with certain values and certain ethical frameworks that are embedded in the system. Do we just take it blindly? So these are really big questions that we need to think about very deeply. What about cultural awareness? What about sensitivity within and across cultures and languages? And there's a sort of like a misunderstanding. A lot of people think because of the sheer size of the web that it's a representation of the world population. It actually is not, even though technically we use it that way as a proxy. We tend to forget that the origin of this is not necessarily, It is not really a reflection of the real views of the world in general. Even when we talk about Arabic, there's a lot of research that we're doing right now, where we notice that a lot of the Arabic that's represented online is not really a reflection of really the Arabic that people, or the value system of the Arabs who speak that language. So, recognizing or decoupling the technology from what's actually representing is actually a key point. And what about multilingual foundational models, like large language models fall into this family of the Stanford coined foundational model rubric? Do they help mitigate or exacerbate some of these problems? And what about this notion of grounding? Is grounding in other modalities something that we could be seeking as a way to overcome some of these challenges? So I would like to just highlight, before going into the depth of my talk, there are lots of kudos that need to go around, but we also as a community, we've done a lot in terms of the NLP community, the CL community. I'd like to pay gratitude to technologies that enable us to think about software engineering. I know this crowd is not necessarily only NLP people, they're probably people from all over CS. So I'd like to acknowledge software engineering, hardware, systems engineering. In fact, some of the challenges we faced at Meta for building the family of first large language models was that we NLP people thought that we could do it on our own. So a lot of us converted ourselves into quote unquote proxy approximate systems people. And then we realized, wait a second, this is actually a science. It's not just necessarily something that since you're a good computer scientist, you could just end up doing systems work. And especially doing it at scale is something really, 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 really challenging. So we're very humbled by that knowledge, to be honest. But there are also sciences that empower us. So think about sociolinguistics, pragmatics, social sciences, cognitive science, core machine learning, statistics. And then the domains that leverage us. I think without the use cases, we would not have been able to actually make the advances we have. So what is the future? With this mainstreaming of natural language processing, we believe we're at an inflection point in our field. Could this turn into a diamond era for natural language processing? I use it as a proxy for AI, obviously because we're the center of the world. So I'd like to say that, if we do well, AI would do well. But how can we ensure the longevity of our field? So how can we sustain us as a field? So this talk is about the vision for the future, or a future for natural language processing and AI in general. So this is just going to be a small preview into the status of our field going forward. This is very simplified. So think about this from the 50s all the way to the current day and age. We have been going up in performance. And is there still room for improvement? What tasks, what technology? Are we asking the same or different questions? What about the scale? So it has been also going up, actually gigantically going up. I'm making this look a little bit, linear, but in fact it's almost been exponential. But the efficiency has gone down. The accessibility has gone down. The transparency has gone down, right, in terms of the buildings that we built. And using NLP as a proxy for AI, what happened, if you think about this from the early 50s all the way till today, we've started off with rule-based systems, gone through statistical and classical AI, to deep learning and end-to-end systems. But really what's happening there is that the explicit linguistic modeling has also gone down. So we started off with very, very explicit modeling of what rules of language we need to embed, to now we just learn it by osmosis, right? What we call self-supervised learning. So the linguistic rules, like from morphology, phonology, syntax, and so on. And the middle part, around the 1990s to when I got my PhD in the early 2000s, we did a lot of feature engineering. So you had to really understand the underlying data and the phenomena, but you also had to figure out ways to use it smartly in a machine learning framework. And now we're into this representation learning framework all the way through, which is really the opaque one. But in the process, so we started off with NLP and CL being very similar, and now we sort of bifurcated, right? So the NLP has become very different from the CL that we see today. And basically, we're losing the CL. We're losing the scientific component of this, which is not a very nice thing. I just want to give you a little sidebar conversation here. So growing up, I grew up in England, and I used to know the difference between a P and a B. Oh, I still know it, right? So it was something that, and we moved to Egypt, and I noticed that nobody could say Pepsi right? Everybody's going Bipsy, Bipsy. And I'm like, what's wrong with you people? Just say pe, and you're going to be able to say it. But they're able to say the P sound, but they're not producing it in a word. And I used to think that these are people who are just lazy, and they're not putting enough effort into learning how to pronounce the P sound. And it's really prejudiced and biased, really, when you come to think about it. And then I came across phonology, which is actually computational linguistics. And that's when I learned that, in fact, this is something that's cognitive. It's not really an aspect of their apparatus. That it's not like they're not able to produce the P sound, or the Japanese are not able to produce the R and the L sound. It's really something about the frequencies that you actually are exposed to at a very early age. But knowing that in itself was actually something that I thought was a really interesting generalization. So it could lead to better, from a technology perspective, could lead to better automatic speech recognition, but also you can think about accented speech generation for, people who are what's called L2 language learners. So you can build better educational systems in terms of recognition, in terms of generation, for example. So having that insight hopefully would lead to, it's actually humbling knowledge. It made me less judgmental, more empathetic, but at least, and I'd say this at least around language, hopefully. But really, this insight could have been driven also from the data, especially given the scale that we have today. So these types of patterns could have been actually derived from the data. But essentially, this is a notion of, scientific enterprise and scientific discovery. And I'm hoping that we could bring that back into the NLP technologies that we're building. So back to the status of NLP. What we have today is really opaque, unpredictable, hallucinations, privacy violations, harmful output, bias, disinformation, misinformation, inefficiencies. So these are symptoms of what I call uncontrolled systems, right? So what is control? Control is being able to control the outcome, performance, and predict it reliably. So this reliability angle is something that we're missing today in our technologies. You put in the right prompt, you get the right answer. You change the prompt by one word, not necessarily in a very substantial way, not necessarily going from positive to negative. You just change the prompt one little iota, and the whole thing changes altogether. This level of unpredictability is something that we do not know how to deal with. And this is actually a very big problem. So the control has gone down, especially with the scale. And in general, where we want to be is, in fact, so the control has gone down, obviously, that's what I was trying to say here. But then if we have a vision for the future, what's the North Star? We'd like the performance to go up, we'd like to have our control go up, and the scale go down. So think about, edge computing, on-device computing, that kind of thing. I'm looking at you, Khalid, because we're looking at the future for us. So could we get there? But how? So in order to control, we need to infuse guardrails, which come from understanding the underlying phenomena. So this is another problem that we have. A lot of us, unfortunately, a lot of people in computer science, and actually even in our field, pride themselves that they don't really understand the data. It's actually a source of pride. Before it used to be a bug, now it's a feature. And the idea is that, I do machine learning, I don't care about the underlying data, I could work with any kind of data. But this is such a wrong way of looking at our field, because if you don't understand the data, you don't get any insights. Hence my example about the phonology problem. And it's also led to a lot of creepy stuff coming out in terms of technology, right? Because we don't understand the cultural nuances, so we end up doing all kinds of snafus. So this learning by osmosis doesn't necessarily work. We need some prescriptive knowledge infused, but basically it's a whole element of research to figure out what the kind of prescriptive knowledge that's needed should look like, how much of it, where do we actually embed it, and actually this entails understanding the phenomena and the nuances and the contexts. So basically, as a side effect, think about this as a gig, the side effect is actually ending up with explainable and transparent systems, which is something that's desirable in general, especially in critical safety-critical types of applications. So what's the proposal? To consider natural language processing technology and AI in general as safety-critical systems. Think about medical devices and airplanes. We're not as bad as that, like hopefully not, if you have the wrong chatbot, you don't crash, but still, it has some negative impacts. We've heard about people, for example, getting arrested for having the wrong translation of something. Like this actually happened to Meta, where somebody translated, our systems translated, a good morning to we'll kill them all, from Hebrew to Arabic. And that person got arrested and so on. So it's a really, it could be critical in fact. So, but it's not as bad as airplanes, obviously, but I mean, close there. So we need more guardrails and regulations. But also central to critical systems is robust evaluation. So think about red teaming, which leads me to, and we have to do root cause analysis and reliable mitigations. But this is something that I also, since I'm here in a general computer science framework, I'd like to highlight is like testing and validation verification are unfortunately considered second-class citizens in any CS discipline. Actually, in the major schools, they've always been considered like, if you do a good if you're a good software engineer, you know how to do testing. And that's such a misperception of what this field entails or should entail, especially now in this era of AI. Building robust evaluation science is something that I think is critical, and this is something that I'm pushing for within even CMU. Is actually not that we have people who specialize in software testing, but they're not considered central to this technology as we speak. And I feel that this is something that needs to be leveraged better. So what is the future of NLP? It should be controlled NLP, which is controlled, what are some of the tenets of that? It has to be safe, accountable, predictable, transparent, private, secure, reliable, and efficient. But also it needs to be usable and has utility, which is central to NLP as a technology. But in order for it to happen, it needs to be trusted and sustainable. So what's controlled NLP? It's safe, accountable, predictable, transparent, all these nice terms that everybody likes to talk about. We've heard these tenets before, and they come from Responsible AI. So it's about accountability and governance, robustness and reliability, privacy and security, fairness and inclusion, efficiency and transparency, explainability and ethical design. So these are some of the dimensions that we highlight in Responsible AI frameworks. So here's my proposal, a Responsible AI framework with some dimensions. This is inspired and informed by many published Responsible AI manifestos, which mostly, unfortunately, came from industry, because they're the ones who had to hit that roadblock when their products came out in the market. So responsible innovation, which addresses the why we produce AI technology that addresses societal impact and human value alignment responsibly. So think about ethical design. Responsible systems addresses the what. What AI technology, covering the research, engineering, and products. So think about the privacy, safety, fairness, robustness, reliability, explainability, interpretability, the resilience of the models that we're building. Responsible research conduct. This addresses the how we conduct our research. And actually, this is technically scientific integrity. So when you think about it, this is what all of us should be doing, regardless of what discipline we're in. But unfortunately, it got lost in translation. Somehow, we lose sight of that. In fact, I'm hardly ever coming across, I remember when I was getting my PhD, we did take a course on responsible research conduct. It was not called that, it was called the scientific method. Now we don't have this in our curricula across the board. I mean, I've been at Stanford, Columbia, GW, Maryland, and now at CMU. And I'm trying now to reintroduce that into our curricula because we're having people learning by osmosis. It's like they read a paper, they think they know how to do research, and we sort of expect them to know how to do research. We ourselves are kind of, light on this. We don't have the rigor, or we don't emphasize the rigor. Not that we don't have it, it's just that we don't emphasize it. And this is really critical to this enterprise, to this framework. And diversity and inclusion addresses the who. Who are the target users, the developers, the researchers, the team makeup, and how can we make also diversity and inclusion extend to the notion of safety in our environments and ecosystems. These dimensions overlap and they bleed into each other, obviously. So can we develop a RAVE mindset, which is basically the basis for responsible thinking? If we are to consider AI technologies critical systems, then we need to produce RAVE-compliant technology. Can we translate this into something that's operational and actionable? So RAVE applies to both AI performed responsibly by us, but also applied and deployed responsibly for the user. It needs to be inherent in our defining, devising, development, and dissemination stages of the technology, both proactively and strategically. So thinking responsibly, by the way, is not an edge or an end stage. It's actually a muscle that strengthens with practice. And this is something that I need to highlight very much and very often. So what is the current practice? Many people in our community work on aspects of responsible AI, but mostly disparately. But the majority is kind of like a typical afterthought or optionality. And it's only, and I've seen this in practice actually at scale when I worked for Meta and Amazon, but also in academia. It's like, okay, now we've done the research, now how can we patch it to make it look like we actually thought about these things ahead of time? Which is not necessarily the right way of going about doing things, right? Because it could affect the way we design things in the first place. And it's mostly confined, to the ethical and limitations paper sections, if ever present. So why RAVE for NLP and AI? It actually has, since our technologies, as I said, they're pervasive, they're becoming ubiquitous. but also the technology is in need for a generalizable star with a more scientific integrity component inherently built in. And it ensures, by definition, ensures human value alignment because of responsible innovation. It emphasizes human centrality and centricity with diversity and inclusion. But it also builds trust, entailing larger and huger and higher user adoption, which is critically an aspect that we think is necessary for the sustainability of our enterprise. So technological breakthroughs with enormous potential that could benefit society are often faced with barriers for adoption, especially if you lose trust very early on. So we need to make sure that the trust is actually baked in. So what is the motivation for adopting RAFE for NLP? It's a framework, I believe, if you have a framework, it serves as a guide creating a space and a trajectory for our field. And a defined framework helps serve the community as a forcing function to think proactively about these dimensions, explicitly addressing them in the design, in the research questions and hypotheses. So, yes, her name is Mona. So the benefits of a framework, if you have random brush strokes, no matter how skillful the various painters are, they don't lead to a Mona Lisa. If we have coordination and we have a framework, that could actually lead to there. So is it attainable? Let's see. So we need to have RAFE from inception to dissemination, and we need to do this at scale. Some of the artifacts checklist. Did we think responsibly? What is the purpose of my work? Is it benevolent? Did we address considerations and limitations? Is my tool, model, system, and so on and so forth safe and reliable? Is it generalizable? Is it explainable, interpretable, sustainable? Did I have full traceability and accountability? Is it compliant? Is it reproducible? And did I address all possible subgroups, for example, as part of my team or part of the target users that I'm considering addressing? We actually developed this at Meta, and we actually operationalized it. That was part of my work there. So at project conception, we think about the intended outcomes. We think about who the research would be used by. During the R&D, how did we do the data collection? How did we do the curation? How did we do the model training? How did we do the evaluation? And at dissemination, did we target the right kind of users? Did we follow the right kind of scientific method for doing this dissemination process? So is it expensive? Unfortunately, it's considered a friction point. So especially in industry, like you're basically you're the naysayer the whole time. It's like, oh no, you can't do this. No, you cannot. We're kind of like the lawyers, but in disguise. We're the technologist lawyers. And they hate us in general. But afterwards, they thank us. So I don't know if you heard about the Galactica thing that came out. So Galactica was a language model. Galactica was a language model that came out of Meta, and we had to take it down within 2 days. And we put it out. It was rushed to go out. They decided to skip the responsible AI thing altogether. They were like, you know what? We know better. They put it out, and of course, it blew back. And it was a really bad thing for us in general, for Meta at the time. And at the time, basically I got media contacting me, and they're like, what's going on? I'm like, you know what? I heard about it exactly the same way you did. I had no idea this was going on. So, but they recognized this. But then again, Meta just dismantled the responsible AI team altogether. They decided, you know what? We don't even need these people in the picture. But anyway, I'm not bad-mouthing Meta. I love them. I still have my stocks. So I need to be good about this. So please go invest, buy Meta stocks. There are potential trade-offs because, as I said, it's a friction point could slow things down. But essentially, there's also this notion of time to market, and this becomes a really interesting consideration. So you don't have to have perfection. This is the other thing. So don't make perfection be the enemy of the good, so to speak. What does it mean for academia? Is this only for industry? Are these considerations only for industry? It's actually, I would say, in fact, it starts with academia. It's like how we build the talent, how we train people. And that's part of the reason I came back to academia is, in fact, I noticed this gap that we have in the talent pool. People come to us and they sort of learn on the fly. Like, we're building the plane and flying at the same time. So one of the reasons I went back to academia was exactly to establish these disciplines around, responsible thinking and responsible AI from the get-go. And there are ethical considerations that be at odds with profit, obviously, but having more voices who are internalized this paradigm could tip this balance. And it could would it create tiers among NLP AI practitioners? Hopefully not, if DNI is taken considerably seriously. So the future of NLP is to be trusted and sustainable. And can RAFE be a way to lead us to that future? So now I'm going to talk a little bit technical, very, very high level, but a little bit more so that it tells you, like, actually this is operational, it actually could happen. So responsible NLP could happen if we have trusted NLP. A responsible NLP could happen if we have a sustainable NLP. So I'll give you one example of each. Within the trusted, how do we attain trust in NLP AI technologies? We have to trust the process, so think about ethical considerations. Augmenting human abilities versus substituting human abilities. Automated decision-making processes versus assisted for sensitive domains, so think about the legal and the medical domains. What about copyright, IP, and plagiarism issues? So if we trust the process and trust the purpose, then hopefully that leads us to trusting NLP. Can we trust the process? Can we build trustworthy development and evaluation frameworks? Can we trust the outcome? So is the outcome safe, reliable, and robust? Is the outcome where it needs to be? Is it explainable? Can we build measuring or metrics that are actually reflective of what people expect? And is there transparency in the dissemination process? So, I mean, these are elements of this framework that I just devised, the responsible innovation, responsible systems, responsible research conduct. So there are many commendable efforts in the community that try to attain this trust, but there are some loopholes that explain the loss of control in the popular scaling domains and paradigms. So there's a lack of deep understanding of large models and the data that's used for training and evaluating them. There's a lack of rigor in annotation processes of both evaluation data, development data, and training data where present. So we need some sort of a science that actually helps us do this in the right way. So this leads to a lack of trust in the process. But also there's a lack of practical accuracy metrics that are commensurate with user perceptions and expectations. There's a lack of reliability and stability of performance, so there's lots of unpredictability with these large-scale models. And there's a lack of transparency. We don't know actually why the results we're seeing are being seen. So basically we have a lack of interpretability and openness. So this leads to a lack of trust in the outcome. I'll give you one example of some solution we've come up with for the first one. So basically, we build large-scaling tools for essentially for trusting the process. So this is a work that we've done at Meta, and the system is out there in the public on GitHub. It's called the Text Characterization Toolkit. Basically, this is a dynamic, lightweight platform and infrastructure that enables easy definition, configuration, and calculation of arbitrary quantitative metrics over very large corpora. So think about corpora at scale. So the large language model training data, that's the scale we're talking about, billions and billions of tokens. And it comprises 61 metrics, and it provides dashboards, standardized Jupyter notebooks, discovering correlations between individual characteristics and performance, and also fits multivariable regression models to predict model performance based on text characteristics. So what was the motivation for doing this? We wanted to build NLP data sets. So basically the idea was that we noticed that NLP data sets were kind of treated as homogeneous sets relying on single summary statistics. And they're known to, these large data sets are known to comprise biases and artifacts of spurious correlations. And summary metrics tend to be very, weak in terms of surfacing some of these aspects. And most available tools for analysis are not easy or scalable. So therefore, we gain no insights into the CL component, like the actual science of why the data is actually affecting what we call influence measures. Why is the data affecting, how is the data actually affecting the outcome, so to speak? So we wanted to gain more understanding and control over this large data by specifically looking at targeting robustness, data selection, and bias. And I think this is the critical part around data selection. This is something that I try to highlight a lot. Right now, the way we operate is that we just take the web and dump it into a training of a large language model, and we think we've done a good job. No data selection, no characterization that happens. And the reason is because you don't have the scaling tools that are able to do the characterization in the first place. And then when you're characterizing, what are you characterizing for? Like trying to identify what are the characteristics that are desirable for you to actually dump it in your training data. So maybe this could be an avenue for us as people who are on the poor side of the world, who cannot afford to have all this compute infrastructure, to do strategic data selection, because we have strategic data characterization, and therefore could build smaller models which have the same impact as the larger models. So this is one avenue for actual scientific breakthrough. So this is some of the categories of the test metrics. I'm not going to go into too much detail. So the current practice is that you have a model and data, you do model predictions, you do evaluation metrics, and just iterate over that process. Now we have characteristics, so basically you can iterate over the data till you get the right characteristics in place. And in fact, you can study the influence measurement, essentially, of what data characteristics you already identified early on, and therefore you can figure out why the performance looks the way it is. And I'll show you this, how this happened in practice. So this is some of the dashboarding that we have different visualizations. I would happen to be working with a whole bunch of excellent people in visualization, which did not have anything to do with my slides. And they essentially, built amazing platform for this visualization aspect. But just to give you a use case of this, we built internally a large language model that's called XGLM, which is 7.5 billion parameters. In the world of large language models, it's technically small, but it was multilingual, meaning that it's balanced across different languages, 16 languages. And we wanted to test to see, if we compare it to an English-only model that's, just dedicated to English, which is essentially the GPT-3 of the same size. We built our own internal version of it. We used the one that's off the shelf, and we wanted to compare the performance across the English portion of the multilingual model versus the English-only language model. And we were constantly seeing that we're failing. The multilingual one was doing much worse than the English-dedicated one. So we wanted to figure out, can we do an analysis of what's going on with the data? And what we found was actually that the distributions of the evaluation data compared to what we use in training were closer in the GPT situation versus the multilingual version. So this gave us a nice insight into what's going on. So this actually interpreted what happened. So I'm cognizant of time. How much time do I have left?
About 10 minutes.
10 minutes. Is there
5 minutes if you want to leave more time for questions.
Okay, 5 minutes. Wow. Okay. Huh. Okay, I always do this talk, and I think that I'm doing it on time, but I'm never, ever on time. So, okay, I'm going to skip over this and just give you the next portion, which is around sustainability. So I hope from a trusted NLP perspective, this showed you one aspect of how to build trust in the data that you're building. Now, looking at sustainability, this is something that I'm also very passionate about. And sustainability of NLP is critical. So how we need to grow in terms of solutions, systems, users, researchers, and developers. And I believe if you're thinking about NLP from that perspective, you need to think about D&I as a cornerstone of NLP growth. In order to ensure longevity of the field, we also need to hit the impact on the environment, so think about green AI. And we need to have more deep collaboration with other disciplines within computer science and linguistics and across the aisle, so to make the discipline stronger and more resilient. And also help shape policies and regulations, allowing our voices to be heard, leading us to shaping the future of NLP investments. So what are the aspects of sustainable NLP? It has to be accessible. It has to be useful. It has to be relevant technology. It has to be maintainable. So we have to have a growing community of researchers and developers. And it needs to be transparent in terms of dissemination of the knowledge through accountability. But it also has to be benevolent. So for societies avoiding harmful impacts, so from an ethical perspective, they should be value aligned. But also for the environment. So think about lowering the energy footprint and cost of use. So these are elements of the RAFE Responsible AI framework that I just outlined for you. And basically, how can we operationalize this? But why D&I? Why should it be a sustainable part of a cornerstone of the sustainable NLP enterprise? Morally, given the utility of our technology, I think it's incumbent upon us to ensure accessibility and adoption by all people, giving them obviously the freedom to choose not to use it, but in fact, having a say in the matter is a critical aspect of this. Otherwise, I believe it's a form of disenfranchisement. And scientifically, D&I serves as a forcing function to think of low resource scenarios. So believe it or not, the languages of the world, 7,000 of them, are minorly covered. We only cover something like 200, not even well. If you think about well, we maybe cover 3 or 4, which is minuscule given the diversity that we live in. So how can we actually think about scenarios where we can, in fact, have impact on low resource communities in general? And when I say low resource, I'm not just talking about the number of speakers. I mean by that digitally low resource, meaning that they don't have digital presence on quote unquote the web, for example. And if we adopt this perspective, even English language has low resource scenarios, right? Think about all the dialects and the accents and so on and so forth. But opportunistically and strategically growing our communities by using our technology to make the science accessible leads to more inclusion and diversification. So how do we do DNI? We need to have more access, increasing the number of users by lowering the accessibility bar, so think about more efficient systems. So handheld devices, for example. Can we have ChatGPT on a handheld device? Can it actually, without having an attachment to the cloud, for example? Can we ensure that our teams are as diverse as possible to reflect different viewpoints? I believe so. A lot of people do a lot of talk about this, but in fact, it's not necessarily actually doable. Because you're always capped by a team size. You cannot get a representative of every culture and every language out there, right? So what is the solution to this? Basically, we need to address this notion by going to homegrown talent markets. And that means that we actually need to take our NLP, our AI, to the local communities and actually use that. So I think I'm exactly at the right place here at CMUQ, where there's an effort to actually create talent in the local market. So this is a critical aspect. And we need to actually do this in a way that achieves this mirroring effect, increasing global NLP values, but also increasing the NLPers by demystification of our sciences, especially at the high school level, generating scientific materials in different languages. And I think this is really critical. So a lot of people think about NLP or sciences in general just being in English, and it is the language of science. But in fact, this creates also barriers in terms of dissemination and in terms of actual absorption. So, and there are lots and lots of studies abound that mention how learning in your local language actually affects your ability to learn and actually grasp concepts. So can we use our technology in service of that? Evangelizing NLP through global media, but also encouraging conferences and outreach programs in diverse locations. Especially, I have a very special place in my heart for the global South in general. What if NLP is not diverse and inclusive enough? It essentially amplifies the global divide, but also deprives the field of the rich diversity and cognitive skills. And basically, we would have failed the mission of actually catering to all peoples of the world in their local languages and their local contexts. And I think of this analogy always around medicine, for example, that caters only to like the white male, which is kind of a known thing of a certain age, where then they start to apply this science to women and to children and to they make generalizations, which is not necessarily the kosher way of doing things. So what is a North Star? To have NLP practitioners and researchers carrying out NLP research in their local languages. So where do we start? From the top of the funnel, I would say. Every STEM program worldwide, of course, has an NLP AI program in their local language. That's kind of the dream. So basically, I'm going to stop here. I just wanted to end on one note so this is how many things I had planned for you guys. So I have this initiative that I started a year and some ago. It's called the 60/60 Initiative around globalization for localization. And the idea is to translate scientific materials into 60 languages by the end of 2024. And basically using our technologies as a way to stress test our technologies, but at the same time, and we're not just looking at text, we're actually looking at all modalities, including speech, text, sign language, videos, images, and so on. And the idea is to have people from different parts of the world who are working in our field, in fact, take on part of this. So it's by the community, for the community. And essentially the idea there is that we build standardized terminology, because one of the challenges of translation in the scientific realm is that we don't have standardized terminology. So this would be a way to curate scientific terminology in the different languages. So if anybody's interested in something like that, please reach out to me. I'm just gonna, stop here and just leave the slide on. So what are the take-home messages? Hopefully mainstream responsible NLP in academia, civic society, and industry. Treat NLP with the rigor of critical systems, adopt a collaborative mindset, especially with DNI as a cornerstone, and proactively think of responsible NLP from inception to dissemination. But also responsible NLP should be the modus operandi for all of us, not just subset or a track. And we don't have to be perfect, but we need to engage and practice responsible AI framework proactively. And think about responsible NLP from a user-centric perspective. It's the magic bullet, in my opinion. They'll bring back the science into NLP and simultaneously build trust with the users and leads to sustainable NLP via efficiency and DNI, increasing our accessibility. Thank you very much, and sorry for rushing through the end of this. Thank you very much.
Okay, maybe we have time for a couple of questions. Thank you very much, Mona.
So, I have to use the mic. All right. Thank you so much for this, Mon. I think we've been around long enough to recall parallels of this. If you just take the word NLP away, whether it's building sustainable, verifiable systems, secure systems, pick your angle. And while I have no doubt about the importance of going in that direction, I'm constantly worried about, do we have the economic model in our corporate world or our general ecosystem that truly incentivizes us to move towards that direction? I'm doubtful. I don't know what your thoughts are about that. It's almost like, okay, it's great to do all this. Who will and why beyond it feels good and it's the right thing to do, but kind of goes against that economic incentive ecosystem we live in.
Yeah, so I could tell you that it's actually been proven that it's actually necessary. So the Galactic experience cost millions for Meta. When they put it out there for 2 days, their stock went down literally that same day by a significant amount. So they recognize the importance of having the responsible AI. And actually, when they diffused the responsible AI team, they did not really dismantle responsible AI within Meta. They actually made them more dispersed with the recognition that they need responsible AI for every aspect of the products that they're building. So this was actually a win for us, for responsible AI community, that's my point. So from an incentive structure, it definitely has paid off for them to do this kind of investment. Now the question becomes, to what extent? So can we reach the level of perfection that I'm talking about? And that's part of the reason I'm saying we don't have to be perfect. So I'm kind of like saying, but just putting the good faith effort to actually be cognizant of it while you're building, and recognize that you're doing trade-offs. So for example, you say, you know what, I know I'm not doing the most perfect thing that I know I could be doing, but there's a cost to market benefit, but this is where academia comes in. So can we expedite or make them more efficient in practice? And I mean, unfortunately, I couldn't go through a lot of the stuff that I've done, but a lot of aspects of this actually paid off. So the work that I did for Arabic NLP within Meta was actually around exactly how to build diverse teams. Because we did notice, we had a big flare-up in 2021, where we noticed that we had to take down something like 350,000 accounts in one day by mistake. And just uncovering that process, we recognized that we're treating Arabic as a single language, as opposed to thinking about this multiple dialectal aspect. So we actually did the scientific studies to prove that, you know what, if you invest in the right kind of diversity, you actually get a better bang for the buck. And in fact, it went all the way up to Mark Zuckerberg, and he approved us doing this research, and we ended up proving it, and we ended up changing the whole way we do some marketization within the Arabic language. But also set the example, so just even though we did this for Arabic, it set the example for other language families, right? So they recognized that the responsible AI aspect of this was actually critical for them. And for them, I mean, in industry, the incentive structure is about making profit. So if you're losing clientele, it's a non-brainer, right? So we were able to dot the lines to make them realize this. But it needs to be, you need to be sort of like, being able to make that pitch, to show them that actually it's going to affect the bottom line. So this is industry. But now academia wants the incentive structure to do this, right? And I would claim it's the scientific integrity aspect. If we're going to produce scientists, we need to think about, have that rigor and have that ethical value system. So another example, I don't want to be going into a lot of things here now, but for example, there's a big movement right now in AI to stop us working in things that are directly or indirectly funding weaponry, especially targeted weaponry for the current situation in Palestine, Israel. So this is something that comes from an ethical perspective. It's not like we cannot do the science. It's actually about us choosing not to do the science. So if you have more people trained that way, recognizing the downside or the sort of like the implications of our work, I think that's going to be critical from an academic perspective. So Just another example.
Thank you very much. Maybe one more question?
Thank you very much for the talk. So several times you mentioned the explainability is also on the slide of AI. How attainable is this, you think? Is it like a matter of time, or is it like still a question of whether this can be done? And
So-
if I can also connect it to the explaining the brain, is there any connection with explaining the brain, or can be done orthogonal to that?
I don't think we should be tying I think we should, in general, this is my perspective, we should be tying the actual neuro component from the neuro models that we build. I feel like, it might be a stretch to link these two things together. They might give us some insights in terms of potentially that would be unlocking some kind of aspect of some latent representations that we have, for example. But to have a tight connection, even though we call them neural models, it's inspired by that, but I don't think it's actually a tight connection from that perspective. But to address your first question, which was, the explainability component, yeah. So I have a huge line of research working on this around interpretability, which is around the actual interpretability of the nodes themselves, of thinking about, activations and what have you. Explainability is a more problematic thing, like understanding why it came up with the solution. In the current autoregressive models, I don't think this is necessarily going to be a very good insight. We try to mimic explainability to some extent through the chain of thought kind of things that's called COT, like trying to get the models to reason about why they came up with a solution. I have recent work that it's in fact under review and under submission around causality versus correlation. So we try to probe that problem space for a little bit to understand, is what's happening to spurious correlations, or are there actually reasoning steps that go behind it which could lead to interpretability and explainability. We're not very successful. But I feel like we have to rethink the whole model architecture. Like the current next word prediction is not necessarily insightful. We need bigger kind of scopes, and this is something that people are working on. And I feel like people working on planning as another alternative way of doing things, like building in inherent model structures that look at planning, might have some insight into how we can explain some of these models.
Okay, thank you very much. I will invite Dean Michael Trick for the closing remarks.
Thank you, but a round of applause. Wonderful talk. And I think an important talk. I think that this really is going to start defining what the next few years are about. And so thank you so much for coming and being the Haberman speaker. We have a memento for you. If you're able to come up, we'll take a picture.
Oh, sorry. Yeah,
okay.
that was it.
Oh, you okay?
No, it's just my, oh, yeah. Oh, I'm done, yes. Thank you.
So thank you so much for coming and joining us.
Thank you so much.
And we'll have a nice picture taken.